Okay, so I'm still figuring all this mess out, but here we go. I figured first project I would try and do is one of the first projects I actually tried to put together a little while ago. I'm a huge nerd, and that involves a big enjoyment of the trading card game Magic the Gathering. Simic for life. And so one of the things I wanted to try and do, or at least see if I could do, is create my own Black Lotus, at least design it in terms of, genetics. So I figured that could be the first fun project that I go over here. And again, any actual experts out there in the field, please let me know of any little things I'm missing, details, etc. That's kind of the point for this whole bit. But anyway, so here's a plasmid that I put together for the Black Lotus. It's been a little while since I've actually looked at it, so I'm going to be kind of going back over everything and seeing, kind of relearning it with you guys here. So, admittedly, this one is kind of tossed together color-wise. I wanted to do several things. One, I wanted the Lotus flower petals themselves to be dark purplish in color. Hold on a second. Okay, had to pause it for a second there while I pulled something. So this is basically the image that a lot of people, that's kind of known as the Black Lotus. And so I kind of wanted to make something that looks roughly like this. Now you'll notice it's not just a black purplish coloration on the petals, fancy skull there, but it's also a bit of a glowing effect. You got some purple glow here, some blue glow there, and all that stuff. So what I wanted to do was I wanted to make a lotus flower with dark purple flower petals, but also had some element of that glow. So what I did is I went and researched this promoter right here. Let's see, which was description. Blarg. I'm pausing all over the place today. Okay, here we go. So, right, for the Black Lotus here, I got the promoter, which I took from, let's see, I believe it was biosynthesis, flower color difference, gene regulation. Yep, so, sorry, call, copy, paste. Yeah, okay, yeah, the same thing. So I got the gene associate. I pulled the gene from here, identification of a R2R3-MYB gene regulating anthocyanin biosynthesis and relationships between its variation of flower color difference in lotus. Blah 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 blah. But the basic idea is that this promoter is expressed within the flower petals. Got a ribosome binding site, which I pulled from here. Now, the ribosome binding site I only managed to pull from, say, I only managed to pull that from, like, the iGEM catalog, so it's not exactly something suited for a Lotus necessarily, so that's one of the major possibilities of failure right there, that the ribosome binding site might not quite work. Always a little bit of a gamble. Then I got purple color here, purple coloration. Terminator, this is back when I was a little bit fresher than I am right now, and so I just grabbed a very strong Terminator, which apparently came from cauliflower virus. And, okay, so this is the weird bit right here. So, one thing I wanted to do, and again, copy that promoter so it's only expressed within the flower petals. This is where I messed up, apparently. earlier. So for luciferase, now I could be very well wrong here, but my understanding at the moment is that luciferase requires not just the protein itself, but a whole little setup of other, proteins and stuff. So I guess this is not really going to glow blue like I thought it would when I slapped it together. But the general idea was that I would hook up the promoter to the luciferase, the glowing blue bit, or the part that makes it glow, and so it would produce that whenever it was in the flower petals. But I also looked back and found an interesting segment of several tags. And remember in that first video where I said sometimes there's little tags and stuff that get attached to things, or not very common. This is one of those instances where apparently the little tag segment, I actually hooked that up to the circadian rhythm within the flower, within the plant itself, so that after, every 13 hours after exposure to light, I think it was. Here we go. Circadian regulation of transcription. I'd probably need to dig through this again to actually make the thing that worked better. But the idea was it'd have to take all these different little sequences. I honestly forget if I just took the dang same thing and just copy pasted it a whole bunch to make dang sure it got read or what. It's been a little while. But this little tag is put before the promoter, apparently, according to the paper, in order to associate it with the circadian rhythm of the plant. And so if you manage to keep a steady, regular, light rhythm, I managed to find it so that this particular sequence activates this promoter, and it will only activate when this sequence is set up around sunset. So the idea was that you would basically have a plant that was like purple too, basically lots of purple and blue. I just threw in a whole bunch of different stuff there, which is probably unnecessary, and there's no kill like overkill, as they say. But yeah, I just wanted to make it look as dark as I possibly could, so I threw in like 2 purples into blue there. But the idea I was going with was that around sunset, the circadian clock would latch on. It'd be expressed only within the flower petals, and then look, luciferase. I'm still not sure if I am right or wrong on that one. Probably wrong, but the idea being that the lotus flower itself, the petals, would glow blue right around sunset when the light is dimming and you can actually start to see a bit more of the glow. You become a bit more sensitive to it, and apparently that's also when this little tag is at its most sensitive in terms of producing stuff. So that's pretty much it. But this is like one of my first attempts to just try and throw together some neat little thing just to try and get some experience in under my belt. And yeah, that's pretty much it. I just took a lotus plant and threw in a couple different dyes here. I don't have a plasmid backbone here, so if you were to actually put this into an organism, you would need like some vehicle or like some framework. Like, you don't just take a painting and nail the painting to the wall. You put it on a frame. You put the canvas on like a wooden frame. You put the wooden frame, you put the wooden shaped canvas itself in a picture frame, and you hang that up on the wall. Kind of the same deal with this. This is just like the painted canvas itself, not the wooden frame, not the picture frame or any of that mess, just that. Here's basically what you would be looking at. And again, I may have messed it up with the luciferase. But anyway, so what you would normally use is a plasmid backbone that you have as acting as kind of a chassis, whatever, to hold the whole plasmid together, or to hold the whole thing as a method of transferring it into the organism in question. You can use that. You can also use it to help with the selection, so make sure that you have the right particular genes or not, depending on what exactly it is you're trying to do with it. But since this would just take forever anyway, and it'd be fairly obvious, on top of not really bothering to put in a plasmid backbone, it just wouldn't necessarily need that. But anyway, this is just the design I put together to try and see if I could put something together. While looking this up, I actually learned a neat little random fact. Apparently lotus flowers heat up sometimes in the winter. Like the flowers itself, not the rest of the plant, but like the flower itself is a slightly higher temperature than its surroundings whenever it's cold out. I just thought that was kind of cool. But anyway, so yeah, that's the Black Lotus. I'll probably come back and like take another crack at this and like redesign it at some point in the future. But yeah, that's pretty much first one I put together. So have a good one.